Operations Management Theory 101. Operations management is the branch of management that focuses on how organizations produce goods and deliver services. It is concerned with planning, organizing, and supervising processes, and ensuring that an organization operates as efficiently as possible. At its core, operations management seeks to transform inputs such as raw materials, labor, energy, and information into outputs that have value for customers. This transformation process must be designed and managed to maximize value creation while minimizing waste, delay, and cost. Whether one is looking at a manufacturing plant assembling cars or a hospital treating patients, operations management provides the tools and concepts for analyzing and improving the underlying processes. The origins and historical development of operations theory. The roots of operations management theory can be traced back to the Industrial Revolution, a period of rapid technological change that fundamentally altered how goods were produced. As manual labor gave way to machines, the need to manage complex production systems emerged. In the late 19th and early 20th centuries, scholars and industrial engineers began to formalize approaches to improving work efficiency. One of the most influential early thinkers was Frederick Winslow Taylor, who introduced the concept of scientific management. Taylor proposed that work tasks should be studied systematically to identify the most efficient ways of performing them. He introduced techniques such as time and motion studies to eliminate wasted effort and standardize labor processes. This scientific approach to work design was extended by Henry Gantt, who developed scheduling tools and charts, and by Frank and Lillian Gilbreth, who studied human motion and ergonomics. Meanwhile, Henry Ford transformed manufacturing by introducing the moving assembly line, which allowed for mass production of standardized products at unprecedented speed and scale. Ford's methods demonstrated the power of designing operations to fit specific production goals. These early contributions laid the foundation for operations as a distinct area of managerial expertise. The systems view of organizations suggests that organizations are best understood as interconnected systems, where a holistic perspective highlights the importance of relationships and interdependence in shaping organizational behavior. One of the most important theoretical developments in operations management was the adoption of systems thinking. This approach views an organization not as a collection of isolated departments, but as an interconnected system of inputs, transformation processes, outputs, and feedback loops. Each component of the system, whether it involves purchasing, manufacturing, quality control, or customer service, interacts with others and contributes to the overall performance of the organization. For example, consider a bakery that sources flour and sugar, uses ovens and labor to produce bread and pastries, and delivers these to customers. The performance of the bakery depends not only on the skill of the bakers, but also on the reliability of suppliers, the scheduling of shifts, the layout of the kitchen, and the timing of deliveries. Systems theory encourages managers to think holistically and to understand how improvements in one part of the operation may affect the rest. Process thinking and workflow analysis. In operations management, the concept of a process is central. A process is a sequence of steps or activities that transforms inputs into outputs. Process thinking involves analyzing these steps to identify inefficiencies, eliminate bottlenecks, and improve overall performance. Process mapping and flowcharting are tools that allow managers to visualize how work moves through a system. In a service environment, such as a dental clinic, the process might begin with scheduling an appointment, followed by patient intake, examination, treatment, and billing. Each step involves different resources, and any delays or errors can affect the overall experience. Process analysis helps managers uncover issues such as long waiting times, redundant paperwork, or underutilized staff, allowing them to redesign operations for better outcomes. Capacity planning and facility design. Another major area of operations theory involves decisions about capacity and facility layout. Capacity planning refers to determining the amount of output an organization is capable of producing in a given period. It includes decisions about the size of the facility, the number of employees, the amount of equipment, and the hours of operation. Choosing the right capacity is critical, because underestimating demand can lead to missed opportunities, while overestimating can result in wasted resources. Facility layout refers to the physical arrangement of resources in a space to support efficient operations. Different types of layouts are suited to different production strategies. A product-oriented layout, which arranges equipment in the order of production steps, is commonly used in high-volume manufacturing settings like automobile plants. In contrast, a process-oriented layout groups similar types of equipment together and is more appropriate for job shops or custom production environments, such as a machine repair workshop. Inventory management and materials flow. Here, the goal is to manage inventory effectively, optimize material flow, reduce costs, and improve overall efficiency across operations. Inventory theory explores how much stock an organization should hold, where it should be located, and when it should be replenished. Effective inventory management strikes a balance between ensuring product availability and minimizing holding costs. Excess inventory ties up capital and takes up storage space, while too little inventory can lead to stockouts, production stoppages, or lost sales. Classical models, such as the economic order quantity model, help determine the optimal order size based on demand forecasts, ordering costs, and holding costs. More advanced approaches include just-in-time systems, which aim to keep inventory as low as possible by coordinating closely with suppliers and producing only what is needed when it is needed. Toyota's lean production system is a widely cited example of this approach, emphasizing continuous flow, pull-based systems, and the elimination of waste at every stage. Quality management and continuous improvement. By focusing on customer satisfaction, continuously improving processes, empowering employees, and making data-driven decisions, organizations can foster a culture of excellence and sustainable performance. Quality is a central concern in operations, and quality management theories have evolved significantly over time. In the mid-20th century, pioneers such as W. Edwards Deming and Joseph Juran emphasized that quality should not be inspected into a product after it is made, but should be built into the process from the beginning. Deming introduced the idea of continuous improvement, where organizations constantly analyze and refine their processes to reduce variation and enhance reliability. Kaoru Ishikawa developed the cause and effect diagram, also known as the fishbone diagram, to identify the root causes of defects. The total quality management movement extended these ideas to the entire organization, advocating a culture where all employees are responsible for maintaining and improving quality. Six Sigma methodology, developed at Motorola and popularized by General Electric, introduced a data-driven approach to reducing defects and achieving near-perfect process performance. Managing service operations. Operations management in service industries presents different challenges from those in manufacturing. Services are intangible, cannot be stored, and are often delivered and consumed simultaneously. As a result, managing variability, customer expectations, and employee behavior becomes crucial. The design of the service experience, from the physical environment to the sequence of customer interactions, has a major impact on perceived quality. For example, in a hotel, operations managers must coordinate room cleaning, check-in procedures, food service, and maintenance. Unlike a factory, where defective products can be reworked or scrapped, a poor service experience cannot be reversed. Theories such as the service profit chain link employee satisfaction to service quality and customer loyalty, emphasizing the human side of operations. Supply chain integration and global logistics deals with optimizing inventory levels, enhancing transportation efficiency, and improving warehouse operations. As organizations have become more global and interconnected, the scope of operations management has expanded to include supply chain management. This field examines how organizations coordinate the flow of materials, information, and financial resources across suppliers, manufacturers, distributors, and retailers. The goal is to create a seamless system that minimizes costs and maximizes responsiveness to customer demand. One major challenge in supply chains is the bullwhip effect, a phenomenon where small fluctuations in consumer demand lead to increasingly large swings in orders up the chain. This effect is often caused by delays, poor communication, and lack of coordination among supply chain partners. To mitigate it, companies use technologies such as electronic data interchange, collaborative planning systems, and real-time inventory tracking. Companies like Amazon and Zara have built competitive advantage through superior supply chain management. Amazon uses advanced algorithms and robotics to fulfill customer orders with extraordinary speed, while Zara controls much of its supply chain to respond quickly to changes in fashion trends and maintain low inventory levels. Technology, automation, and data analytics. Automation streamlines processes, data analytics drives informed decisions, and technology as a whole enhances operational efficiency. The rise of digital technologies has transformed the field of operations management. Concepts such as Industry 4.0 describe a new era in which digital systems, smart machines, and data analytics are embedded in every part of the production and service process. Automation, artificial intelligence, and machine learning are now used to optimize scheduling, predict maintenance needs, forecast demand, and even make real-time operational decisions. In manufacturing, digital twins, virtual replicas of physical systems, allow managers to simulate different scenarios and anticipate problems before they occur. In services, chatbots and self-service kiosks reduce labor costs and enhance convenience. Data analytics provides insights into customer behavior, process performance, and risk exposure, enabling more informed and agile decision-making. Sustainable operations and ethical responsibility. In recent decades, operations management has increasingly grappled with issues of sustainability and social responsibility. Traditional goals, such as efficiency and profitability, are now joined by concerns about environmental impact, ethical sourcing, labor standards, and long-term resilience. Theories of sustainable operations management emphasize the need to align operations with the principles of the triple bottom line, which focuses on people, planet, and profit. For example, companies are redesigning supply chains to reduce carbon emissions, adopt circular economy principles, and ensure transparency about sourcing practices. Patagonia, a clothing company, has built its operations around ethical labor, environmental stewardship, and repairability of products. Unilever uses life cycle assessments to evaluate the environmental impact of its products from cradle to grave. These examples reflect a broader shift toward viewing operations as a vehicle not just for efficiency, but for positive social and environmental change. Conclusion: the expanding scope of operations theory. Operations management is no longer just about manufacturing efficiency or cost reduction. It is a dynamic, interdisciplinary field that addresses complex questions about how value is created, delivered, and sustained in a rapidly changing world. From the structured routines of assembly lines to the personalized interactions of service encounters, and from global logistics networks to artificial intelligence systems, operations theory provides the frameworks and tools for understanding and improving the way organizations work. As the global economy becomes more interconnected, digitized, and sustainability-focused, operations managers will need to integrate traditional concepts with new technologies, ethical imperatives, and strategic thinking. The future of operations management will depend not only on tools and techniques, but also on the ability to think critically, adapt creatively, and design systems that are both high-performing and humane. Stay tuned for more insights into business and the social sciences. If you found this overview helpful, don't forget to like, subscribe, and comment on future topics you'd like us to cover. I'm Dr. Dag, wishing you a fantastic day ahead.